Technological innovations through the Drought-Tolerant Maize for Africa project, DTMA, have provided a platform for the expansion of maize production, which is now extended to ecological zones that were once considered too dry for maize production. This TV production is an instructional package aimed at educating the farmer on modern methods of farming maize for increased productivity. Although there are over 40 DT maize varieties developed for Nigerian farmers, only 4 were used in this production. These 4 were 2013 DTE STR White Synthetic, 2011 TZEE White STR Synthetic, TZEE White Pop STR 104, and 2013 TZEE White DT STR. They were used alongside the Farmer's Choice variety in 2 different farms. Sit tight and enjoy the program.
There are 3 plots.
3 plots.
Yes.
The 3 plots.
We give each farmer 2 varieties. 2 varieties. One of the varieties the farmer is to supply. So the first plot here will be our own variety.
Which is this one you're holding?
Which is this 2013 DTE. That is the name of the variety. 2013 DTE STR White Synthetic. That is plot 1. Then we have plot 2 is going to be the farmer's variety. That's the farmer's variety. Plot 3 is our second variety.
2 farmers were selected for this demonstration, and each farmer monitored and participated in the demonstration trial of separate farms. Each farm was also demarcated into 3 plots, with each plot measuring 100 meters square. Drought-tolerant maize varieties were planted in plots A and C. Plot B, which is the control plot, was planted with the Farmer's Choice local maize variety. Before the planting of the maize seeds on all the plots, the lands were sprayed using 4 liters of glyphosate to control weeds. It was also ridged 75 centimeters apart using manual ridger.
So from here, this is our first stand. From here to here is 25 centimeters. So every mark is 25 centimeters. And we are going to plant 2 seeds per hole. During first weeding, we tint 1 plant per stand. This is the farmer's plot. This variety is the farmer's variety. He has the name. He has his name that he used to call it. This is our 3rd plot, where we have our 2nd variety. We had the first variety and the first plot. The 2nd plot is the farmer's variety. The 3rd plot is our 2nd variety, which is this. And we are going to plant the same pattern we planted the first plot. This is 25 centimeters. 25 centimeters. In case they fail to germinate, gap filling, or replant, or replant. This is our 2nd demonstration plot of Dan Hassan. This is Alhaji Magaji Abdullah's farm in Dan Hassan, rural local government. It's the same pattern of planting, but different varieties.
This 2nd farm was also demarcated into 3 plots like the first one. with plot B in the middle as the farmer's plot and plots A and C as the demonstration plot.
In plot 1, we have TZEE white 104. This is plot 1. In plot 1. Plant spacing is 25 by 25 meters square. 2 seed per hole. Later it will be thinned to 1 plant per stem. Plot 2 is the farmer's plot. The farmer is free to plant according to his will, and he is to supply the variety. This is the farmer's variety for plot 2. The farmer will plant his variety here according to how he wishes to plant. Either he can follow our pattern or he can follow his traditional pattern of planting. Then the third plot is 2013 DTE W STR in plot 3. As you can see, weeding is going on. The crop or the plant is just 2 weeks old. It's exactly 2 weeks old. As you can see, they are thinning.
2 weeks after planting, the farmer weeds, thins, and refills the gaps where necessary. After that is done, he applies fertilizer to the plant.
The plant is just 2 weeks old. You remove, when thinning, you remove the weak ones from the healthier ones. The weak ones, you remove from the healthier ones. Where the gap is too wide, you can transplant. You may transplant. This is how you do the transplanting. This is MPK fertilizer, 15%. That is 5.5. This is 3 kg urea mixed together. Make sure they are thoroughly mixed. When applying the fertilizer, you use 1 can of fertilizer to each stand, and you apply at 2 weeks. The plant is 2 weeks old today. You apply at least 5 centimeters away from the stem. Now this is our fertilizer, so we apply here, then you cover. The essence of covering, the essence of making the hole and putting the fertilizer covering, it one, prevent aeration. When you just pour it like this, you just pour it like this, like this. As soon as the sun hit it, the nutrient will evaporate to the atmosphere. Or rain, as soon as rain drops, rain falls, it will wash it to the furrow, so the plant will not make use of it. So when you dig hole and put it inside, one, it prevents the sun from hitting the fertilizer, so, and it takes longer time to work in the plant rather than just pouring. Supposing this one will take 2 weeks working on the crop, this one will take only 5 to 7 days. It's exhausted. And leaching is easier, takes place faster when you just pour it on the surface and go. But once you put it inside, it quickly absorbed. The plant quickly absorbs the nutrients. So one thing is how it will be applied. Our crop today is 5 weeks old. As you can see, this is the second fertilizer application. After applying the fertilizer, they will remold to cover the fertilizer up. So this is what we are going to do today. As you can see, this is farmer 1. The second application has been done. Molding has been done. So what was done in the first farmer is the same thing that is going to be replicated in the second farm, Alhaji Magaji Abdullahi's farm.
By the 10th week after planting, the agricultural extension technologists and the farmers visit the farm to monitor the performance of the plants. During monitoring, they collect data on the crop vigor score, which is aimed at scoring the performance of the crops. They look out for the plant height, the ear cover, ear height, cob length, and the overall performance of the farm. This data collection helps the agricultural researcher in his activities,
which is aimed at scoring the crop performance, how the crop look like, the height, how greenish the field is, how tall it is, how stunted it is. That is what is meant by crop viewing. We have to take the vigor scores today, also take the plant height, the plant ear, the crop or ear scores. We take the ear scores. We take the length of the crops also. Is the crops too tall, too short? This will also help the researcher in his future activity. We've come to the end of our monitoring and data collection, and from the look of things, I think, in my own observation, all the plots, including the farmer's variety, are looking good. Indeed, the crops, particularly our main trials, the crops are good, and the ear are fully covered, the canal are fully filled. Yes, the only difference is that the farmer's variety is taller than our variety. But finally, from what I have seen, they are looking promising, all the varieties.
This is the 12th week after planting, and the demonstration plots are ready for harvest. 3 middle ridges have been selected from each of the plots on both farms for harvesting. In these sacks are the harvested maize from the first farm, with the farmer's choice local maize variety in the middle, while the first and third sacks are the proceeds from plots A and C. This clearly shows that improved maize varieties are high yielding.
The farm of extension agents perform much better than our farms, especially in terms of size of crops, high yield, and it was even ready for harvesting before ours. As you can see, my farm is not dry enough to be harvested. I have been farming my own choice of maize variety for long now, but it was due to lack of awareness of these DT maize varieties. This demonstration has exposed me to DT maize varieties and also technologies of farming which I intend to adopt now as my own varieties and techniques for the next season farming. I also make sure that I spread the knowledge acquired from this demonstration to all my friends and neighbors because I have really been educated now. The main reason why I have to adopt this use of DT maize varieties is because from the demonstration it is obvious that the varieties are early maturing much more than our traditional varieties. I can even decide to take the harvested DT maize home now to prepare food, which my own variety cannot do for now. I also like the modern way of planting and fertilizer application. Burying the fertilizer in holes close to the base of the plant has proven to be more productive than our method of applying it on the soil without burying. The rain washes it away when it falls.
Here is a review of the lessons learned in this package. After the land had been cleared and ridged, the farmer plants 2 seeds of an improved variety of maize per hole and ensures a space of 25 centimeters between holes. 2 weeks after planting, the farmer comes back to weed his farm. He also thins out, which is ensuring that only one stand remains at each point. There is also gap filling, which is transplanting the good thinned out plant at points where there was poor or no germination. Still within 2 weeks after planting, the farmer applies the first fertilizer. He ensures that he applies the fertilizer 5 centimeters away from the base of each plant. 5 to 6 weeks after planting, the farmer comes back to weed and apply fertilizer for the second time, using the same method and measurement as he did the last time. By the 7th to the 10th week after planting, the farmer comes back to assess the performance of his farm regularly. And about 12 weeks after planting, the maize farm should be ready for harvest.